This is Mr. Nabi from Roger Bacon High School. This lesson is on the complex numbers for Algebra 2. We'll begin with the quadratic equation at the top of the screen, x squared plus 3x plus 4. And we want to sketch that graph. You can do that by hand or using technology. But the vertex would occur somewhere around negative 1.5 for the x value, and almost 2 for the y value. And it would cross the y-axis at 4. So just a rough sketch of that graph. You could also use technology to make the graph. But if you notice, this graph doesn't cross the x-axis. There are no x-intercepts. We'll take a look at the quadratic equation and how that shows us that we'll not have any x-intercepts. Using the quadratic equation, we know that a is 1 because the coefficient on the x squared is 1. B is 3 because the coefficient on the x term is 3, and the constant c is 4. Now, using the quadratic equation, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, gives you negative 3 plus or minus the square root of, well, b squared is 3 squared, so that's 9, minus 4 times a was 1 and c was 4, all divided by 2 times 1. And we can simplify that down to negative 3 plus or minus the square root of negative 7 over 2. And we said in previous lessons that there will be no solutions to this problem because you cannot take the square root of negative 1. This is not a real number. There's no number that you can multiply by itself to give you negative 7. So because of that, there is no answer to the square root of negative 7. This is not a real number. However, we can express the value of this number by using complex numbers. And here's the definition of a complex number. We're going to use the letter I to stand for the imaginary part of a number. Since we said this number is not a real number, whatever's not real must be imaginary. So really what we can do here is write this as the square root of negative 1. And that's what the value of I represents, the square root of negative 1. This is not a real number, it's imaginary. But we use imaginary numbers to help us continue to solve problems that don't have real number solutions. So going back to our original problem of negative 3 plus or minus the square root of negative 7 all divided by 2, we can write this answer as a complex number by doing this. Negative 3 plus or minus, well, the square root of negative 7 is the same as the square root of negative 1 times the square root of 7. Now that makes sense because if you do the square root of negative 1 times square root of 7, you get the square root of negative 7. All divided by 2. And that simplifies to negative 3 plus or minus the square root of 7I, all divided by 2. All I did was I replaced this term with the imaginary unit, which we're calling I. And now I've got my expression. So here's the final answer to the question of what are the x-intercepts. There are no real x-intercepts. These are only imaginary numbers. And this is called a complex number because it contains both real parts, this is the real part of the number, negative 3 is a real number, and it contains an imaginary part. Imaginary part. The square root of 7I is an imaginary number. Now that we know that I is the square root of negative 1, let's perform some operations. And I'm going to go over some problems that you're probably familiar with already as a basis for what we're going to do. And we'll start off with example number 1. If I want to do 3x plus 5 plus 2x minus 4, I have to combine like terms. Combining the x terms gives me 5x. Combining the 5 and the negative 4 gives me 1. If I want to multiply these two terms, I have to FOIL. So we'll do that. 3x times 2x is 6x squared. first times first. The outside terms, 3x times negative 4 is negative 12x. The inside terms, 5 times 2x is 10x. And the last terms, 5 times 4 is negative 20. And I can combine these two middle terms to give me 6x squared minus 2x minus 20. So this is an example of two problems that you already know how to solve. We'll apply those same concepts to complex numbers. Now, what makes this a complex number? We have a real part. The positive 5 is real. And we have an imaginary part. 3i is an imaginary number. Here we have a real part and an imaginary part. Well, we're going to combine like terms just like we did in the previous example. 3i and 2i are both imaginary parts. So we will combine those and get 5i. 5 and negative 4 are both real parts. We will combine those and get 1. When we distribute, we do the same as we did with variables. 3i times 2i is 6i squared. Outside terms is negative 12i. Inside terms is 10i. And the last terms are negative 20. I can combine the middle terms to get negative 2i. And I can actually simplify the term I've underlined, 6i squared. Well, if you know that I is the square root of negative 1, then I squared must mean the square root of negative 1 squared. And if we square the square root, we get the fact that I squared is actually just negative 1. So this is really 6 times negative 1 minus 2i minus 20. 6 times negative 1 is negative 6 minus 2i minus 20. And now we have a total of negative 2i minus 26. Again, we have an imaginary piece and we have a real piece. Negative 2i is imaginary. Negative 26 is real. Alright, one more example. I want to solve for x in example 2. I'm going to simplify the problem by first dividing everything by 3. That gives me x squared plus 16 equals 0. Now to get x all alone, I cannot factor this. There is no factorization for x squared plus 16. So the only option I have is to try to get x all alone. So I'll do that by subtracting 16, and I get x is equal to plus or minus the square root of negative 16. Now what does this simplify to? Well, this is going to be an imaginary number because we cannot take the square root of negative numbers. But I can write it as the square root of negative 1 times the square root of 16. Using what I know about imaginaries then, I know the square root of negative 1 is the same thing as I, and I know the square root of 16 is 4. So our final answer is that x is equal to plus 4i or negative 4i, plus or minus 4i. Either one will work as a solution. Okay, there are your practice problems. Good luck.